Assalamu alaikum warahmatullahi wabarakatuh. So let us answer the last question that I think I'll answer with you this time. Is the West mock question 5. So the question is simply saying that the capacitor of 8.0 microfarad powered by a 12.0 volt battery supply was in a vacuum, right? And after some time, the capacitor was charging. Before it was charging, they inserted a dielectric. That the dielectric has a value of 6 multiplied by the epsilon naught, epsilon 0, that is the permittivity of free space. Now they're saying that we should calculate the charge stored in the capacitor. We know that Q is directly proportional to V experimentally, and Q equals to CV, where C is the proportionality constant. And now the proportionality constant is what we call the capacitance. Is it clear? Now, if you do that, you just have your Q equals to CV, just substitute your values, 8.0 microfarad times. So you know that farad and voltage gives you a coulomb. So you have your coulomb, but the micro is hanging here. I know that 1 microcoulomb is 1.6 times 10 to the negative 6 coulombs. Please, this is the best way to convert units, right? So this is the best way you can convert. No need of mastering that this equals this. Just set in such a way that the coulomb should cancel. If the coulombs cancel, what will be left is what? If your microcoulombs cancel, what will left be the coulomb? And that is the value. And the B part is saying that explain the effect of dielectric on the capacitance of a capacitor. Well, you know that experimentally, C, a capacitance, is equals to surface area of the capacitor multiplied by the dielectric divided by D. So where A is the surface area, D diameter, and things like that. So if AD is the diameter and the area for a certain capacitor, it is a constant. It means that C is directly proportional to epsilon, or C over epsilon equals to K. In other words, C1 over E1 equals to C2 on E2. In other words, C2 will now be equals to E2 C1 over E1. Do you see that our original capacitance, which was the ratio of C1 on E1 is an epsilon, it has no units, it's dimensionless, okay? So we now have E2 C1 on E1. So E2 is the new dielectric, and we are multiplying it by this. It means that C2 will what? Increase by a factor of E2. So you can now say that capacitance increases with an increase in dielectric. So they are directly proportional to one another. Just from this here. Okay, that is that. Then they are saying that is the relationship. So when I determine the energy stored by the capacitor after inserting the dielectric. Now that you have inserted the dielectric, the new capacitance of the capacitor will change. What factor is it going to change with? So that is what we are going to do in this slide. Now we are having Q. The energy stored in the capacitor is simply QV on 2, which is where Q equals to CV from behind. And if you replace CV here, you just get CV squared on 2 multiplied by a half. So you just get now half CV squared. And now the C now is the one that is now having a new dielectric that have been inserted to it. Initially was in a vacuum having a dielectric of epsilon 0, right? But now that is the permittivity of free space, epsilon 0. But now that they have inserted another dielectric, then the capacitance have to increase with a certain number. So what is that value that the capacitance will increase? You know that the C2, the new capacitance, will simply be what? From here you see that the C2, the new capacitance C2 will be equals to C1 on epsilon naught multiplied by E2, the new epsilon. And they tell you that the new epsilon is 6 epsilon naught. So you now get C1 on epsilon naught multiplied by 6 epsilon naught. You see epsilon naught cancels. And you get C2 to be equals to 6 C1. That is now the new capacitance after inserting the dielectric. Now energy in a capacitor is equal to that half C1 on epsilon naught, or that. So we now get C2, which is what? Half. Now we get the energy to be half into C. We get the energy to be half into C1 times 6, which is now our C2. All that multiplying by 12.0 volt, but you make sure you square the 12.0 volt squared. If you square that, you just simply get 3,460 microfarad volt square. You can allow an answer like that, but if you like, you can continue. That micro is 10 to the negative. Farad volt squared is joule, so 3,460 microjoule. So this is how you should get this question done, and thanks for watching, and I wish you all the best. I think this is the last question will help for those students on the AFCO 2024. Thanks for watching and have a great day. Wish you all the best. Please subscribe to our channel and make sure you share to your genius who are in lower seat. They should also come and benefit. Thanks for watching and see you then.